So it's a small group. This is great. We can be informal. I don't know if I can see people raising hands, but I guess Kirsten could let me know in some way. So what CEOTR is really a blanket organization for a group of technicians that are funded by the Ocean Frontier Institute, by the Ocean Tracking Network, and by the Marine Environmental Observation, Prediction, and Response Network, which technically ended March 31st of this year, but has a one-year no-cost extension, MEOPAR did. So CEOTR is not an actual thing within Dalhousie. It's just a branding exercise because it got really hard to say the OFI, OTN, MEOPAR funded group. So, and of course we had to call it CEOTR because there are so many CEOTRs on the East Coast. So we're a large group of technicians. We do a lot of different things. We have a field group, Adams glider group, a data group, and then we also participate in the Bedford Basin time series. So at any one time, there's anywhere from 15 to 20 people in there with a large variety of skill sets that we make available to researchers, not only at Dalhousie, but also to other agencies. For instance, CMAR, we've done missions for them. So we are approachable. And we have a large user base, a lot of different people that we work with, either as partners or collaborators, or they are clients. All right, so when I was writing this talk, I was having a little trouble organizing it. I was going to go kind of chronological through my career, but it didn't really make a lot of sense. And then my wife suggested a different scheme that I think is going to work. We're going to talk about vandalism from different sources. And for the purposes of this talk, vandalism would be just any buoy damage, whether it's intentional or unintentional. But we'll just stick with the theme. So I'm going to start with a program that began in the mid-90s called the Center for Marine Prediction. So this was a program that was funded by the Canadian Foundation for Climate and Atmospheric Studies. The idea was that we would marry observations to modeling efforts, both in the water and atmospheric modeling, to actually start doing predictions of the marine environment. So as part of that, we put 3 automated buoys in Lunenburg Bay, which actually turned out to be a great place for the modelers and a terrible place for biologists because the dynamic signal there is very low, but that's a different story. So, it took us a few years to get some traction. We got the buoys out, and then we got the whole system integrated by 2007. And then there was an election, and a new government came in that was less concerned about climate studies. And not only did they pull our funding, they also defunded the entire foundation. So we were left with $4 million worth of hardware just sitting on the ground at that point. And these are just some pictures of the buoy system. I particularly like the one with the blue nose in the background. But while the buoys were in the water, and they were in for about 4 years, we actually had no significant problems. And I think we can attribute that to that we had extensive consultation with the local fishermen before we went in the water. So we met with their fishing association. We went to the town and talked to the town of Lunenburg. And we also talked to, key individuals who had, influence within the community. And then the other thing that we did is we hired local contractors as much as possible, right? So, if we needed a shed built, we hired local people to do it. And if we need to go on a boat, and that's always appreciated when you start spreading the money around and you're talking to them directly. And then the other thing we did is we gave access to the real-time data to the lobster fishers. And we know for a fact that they were checking the bottom temperature to see, because the lobsters move as a function of the temperature of the water. This is not to say that we had no problems. For whatever reason, they kept stealing our radar reflectors. But that's pretty minor in the grand scheme of things. We never had any significant damage to the buoys. So anyway, we had these buoys on land. So about that same time, a few years before, Bill Lee at DFO started the Bedford Basin Time Series. So some of you may have heard of it. They go out every week, typically on a Wednesday, and they sample, and they've been doing it since 1992. It's a very powerful time series. There's a great paper that Bill Lee wrote showing that Bedford Basin could be treated as a proxy for the Scotian Shelf. So that measurement's there. There's a time lag, but what's happening in Bedford Basin is happening out on the shelf. And it's a lot easier to get there and sample. So we were talking to Bill and talking to DFO, and we mentioned that we had all this buoy hardware doing nothing. And they mentioned that it would be very handy if we put it into Bedford Basin. So we started the Bedford Basin Optical Monitoring Buoy program. So it was deployed in 2008 with one of the buoys from Lunenburg, which also started us sampling too, by the way. So now we've been going on in Bedford Basin, well, since 2008. So what is that, 14 years now, something like that? And as a side note, I got some great advice on time series once is, two things you need to know about time series is one, never start one, and two, never stop one. So we're going to continue this, well, at least until I retire. So anyway, we had the buoy out in Bedford Basin, and then during one particularly windy day, the pilots were anchoring a large vessel and decided that our buoy was in their way. So they tied a rope around it and tried to tow it off, which was really interesting because it was anchored by 4 railroad wheels. So about, 1,500 pounds. They did not succeed in towing it, but they did succeed in stripping off a good chunk of the surface sensors and damaging some of the solar panels. The lessons learned from this episode was that it's great to talk to stakeholders, but you have to talk to all the stakeholders, right? And we let Halifax Traffic know what we were doing, and we put out a notice to mariners via Coast Guard, but we neglected to talk to the pilots, right? And there was not enough cross discussion between these groups for them to know what was going on. We also need to label the gear better. So you can see there's phone numbers down around the buoy, the base of the buoy. I don't know if they couldn't read it or didn't bother to read it, but nobody ever called to say, hey, you got this buoy here, what's going on? And of course, we also decided to change the design later on. We got rid of the solar panels because if you're in Bedford Basin, you can easily just go out and change the battery pack on a regular basis. I like the picture on the left because it shows the rope they used on the buoy. That's a 1-inch rope. I looked it up. It's got about a 40,000 pound breaking strength. I still have that rope hanging in my office. So just to remind me of things. Actually, this whole incident was kind of interesting. I got to play detective for a couple of weeks, trying to find out exactly what happened to the buoy, because we just came out and knew it was damaged. It turns out Halifax Traffic records all the radio traffic and stores that. So I was able to go back and actually listen to what they were saying to each other while they were doing this. And then right about the time they decided to tow the buoy, they also decided to shift over to their cell phone and got off the radio. It was all quite interesting. But anyway, if you're talking to Halifax Traffic, be aware that they're recording it. So we changed the design of the buoy and we put it back into the water, and it was out for maybe 8 months or so. And then we went up there one day and the hull was damaged. So between a lack of funding, we were bootlegging this whole program, and no lack of frustration, we decided to remove the buoy out of the water. There's no real lessons learned out of this part, except of course that, jet skis and booze don't really mix all that well. But we do have plans to put a profiling winch on the DRDC barge out there in Bedford Basin. We've acquired the winch. We're making some modifications to it, and we hope to have that out later this summer. And so we'll go back to having regular measurements there, not just the weekly stuff. All right. So those are 2 examples of intentional and unintentional damage to buoys by humans. This is another example of, I'm going to call unintentional buoy damage. So OTN, the Ocean Tracking Network, they acoustically tag about 130 species of marine animals. All the way from great white sharks and bluefin tuna down to jellyfish and sea cucumbers. And yes, there is somebody who's actually tagging jellyfish. Don't ask me how he does it. I don't know. Carefully, I would imagine. They've got over 2,000 receivers deployed worldwide in the ocean. And about 250 of these receivers are on the Scotian shelf. And I've written one every 800 meters. That's incorrect. I apologize. There's one every 800 meters. Stretching from Halifax Harbor out to the shelf break. And the idea there is that any animal that swims by this curtain will get detected by this line. The tags typically have a range of around 500 meters. So the map on the left is the AZMP, the Atlantic Zonal Monitoring Program, which is a DFO program, their Halifax line, and it's just a straight line that goes out from Halifax Harbor to the shelf break. The map on the right shows the line of receivers that OTN put out. So it was originally designed and planned to go along the Halifax line, but after talking to, again, the fishermen who work out there, particularly the ground fisher, it was decided to put that dogleg in because the area offshore from the straight part is fished rather heavily. And so the fishermen said, hey, if you just move your line this way, you'll lose less receivers. And the other thing that OTN does, of course, is they try to broadcast the positions as much as they can. So there is a notice the mariners always put out. And then several years ago, they developed a custom chart for the OLEX system, because apparently a lot of fishermen, particularly the commercial fishermen, use this navigation system. And it was easy for them to attain, and it told them exactly where the receivers are. They still get fished up, right? I mean, the fishermen often don't bother to check, or if they do check, they don't seem to care. So there's a few receivers lost every year. But in general, out of 250, they're doing pretty good. So again, this is an example of you need to talk to the people who are working in the area. All right, so I'm going to treat gliders as buoys because essentially they are just moving buoys. So Dalhousie has the largest and most active glider group in Canada. So with gliders purchased both by the Ocean Tracking Network and a project for the development of automated marine observing systems, a CFI project. It was started back in 2010, so we've been doing this for about 12 years now. And we support a lot of different activities. One of our main ones now is marine mammal monitoring. So we put gliders out with passive acoustic monitoring systems on them. Nowadays, primarily in the Gulf of St. Lawrence. The gliders are able to transmit information back in real time, and that data is received by the DFO and Transport Canada and is used in their dynamic management scheme for the Gulf. So that's been about 2 years now where we've been part of that live system. So if a glider says there's a whale in the area, they will enact either a ship reduction or even close fisheries. And then there's a variety of other things that we do, including tag detection, which we did a mission for CMAR using one of our surface vehicles. So to date, we've flown over 128,000 kilometers. So that's greater than 3 times around the world at 1 kilometer an hour. So we're very patient. We've had almost 150 missions now and 4,200 glider days at sea. So we operate 2 different kinds of gliders. The profiling Slocum gliders, which use, they're buoyancy driven. They can change their density by changing their buoyancy, and then they either sink or rise accordingly. And then we have surface vehicles. In our case, it's wave gliders that use differential orbital motion of the waves to drive them forward. I particularly like the transect you're seeing on the left, which was we sent a glider out to the shelf break and back. If you look at the track, you can see that the glider was deflected because it ran into a warm core ring. And you can see the ring in the middle of the transect where the water temperature all the way up and down the water column just jumped up dramatically. And I love that figure because this is the kind of information that's really hard to collect via ships. right? But gliders are slow, they go out there, they're persistent, and they are very useful tools for monitoring. They can't replace ships, but they can do a job that you just can't do with research vessels. So now I'm going to talk about a different source of vandalism, and it's animals as vandals, right? So before we were talking about people. So, you know, the ocean is full of a lot of different animals. So we had a profiling glider deployed on the Scotian Shelf in June of last year, and we noticed that it was becoming hard to navigate, right? And had a dramatic change in its velocity. So we go out to pick it up. The picture on the left, you can see the glider with one wing on and one wing off, and it's kind of listing. And in the picture on the right, what you're looking at there is the wing rail. And normally that black part that's got the part of it that's sticking up doesn't have that part sticking up. It's a narrow slot that the wing goes into. So something hit it. We don't know what. Unlikely a boat, just because of the nature of the damage. It looks more like an upthrust. So a large animal struck the glider and took that wing right off. So the lessons learned in this particular scenario is you got to monitor your performance of your autonomous vehicles, right? So you got to know when they're having issues. You need to have a recovery plan in place. And you need to act decisively. So this is where Adam is really good about this sort of stuff. The moment they noticed that there was a problem, they enacted the recovery plan. And they went out and got the glider before there was any more damage or loss of the glider. So. Sharks love wave gliders. For whatever reason, they keep attacking them. So we had a glider out near Sable Island. Actually, it was just off the deep gully. And it also became unable to steer. So we once again enacted our recovery plan and went out and got the glider in a very dramatic nighttime recovery. I just wanted to say the word dramatic. It wasn't that dramatic. You can see the picture on the left is the rudder assembly. So that part above it, that's plastic that the shark decided to chew up. The part below it that you can also see is damaged, that's titanium, right? So whatever shark was attacking us really wanted to bite this. Based on the tooth fragments that we recovered out of the plastic, it was most likely a porbeagle shark. And this would be the second time that we've had a glider attacked by a porbeagle. We haven't figured out a way to mitigate this yet, and I would love to get suggestions. I mean, there's not much you can do to stop a shark from attacking your equipment. So you just got to have, you know, plans in place for when it does happen. And then the last thing I'm going to talk about is the ocean as a vandal, right? So you can get damage just because of where you are. So this was actually my very first buoy experience. I was working for NOAA in the States, and we were deploying the buoy Peggy out at Station M2. So if you see the map on the left, you see a large black dot just above the archipelago. And that buoy has been deployed now continuously for 25 years. But this was its actual first deployment in March of 1995. By 17th of March, just 4 days later, strong winds had pushed the pack ice 100 kilometers south. And it sheared the surface buoy right off the line. Now, the buoy had an Argos transmitter on it. We knew where it was. It wasn't sending live data back then. There was no Iridium. But we at least knew where the surface buoy was. But fortunately, the undersea instruments, they continued to perform. And so we were actually able to write a paper based on the under ice measurements of temperature and salinity and fluorescence. And it's one of the earliest recorded instances of under ice measurements. Now, it's true we didn't plan it, but we still got them. So the lessons learned here is you need to always check your climatology, although in this case, winds like this were very unusual in the Bering Sea. Having subsurface flotation on the line, if you have subsurface instrumentation, is important because even if you don't get the measurement, you might be able to recover your sensors. We recovered none of the surface sensors. The buoy was damaged beyond repair. And it's the same thing. You got to have a recovery plan. You got to have a boat available. I mean, we were able to get out on the 29th of April, which is pretty good for getting out into the Bering Sea. I mean, so, and we had to, redirect a NOAA vessel. But at the end of the day, we got something out of it anyway. So that's it. That's all I was going to talk about. And it's exactly 20 minutes, so I was right on time.